volume is? The raised hand. Kieran. What does it sound? What does it sound like? It doesn't have to be an educated answer. Just the space. What?
Space taken up.
The space not taken up by an object, but inside an object. Good. So the things that you're going to need to know. So you want to start these on your notes. You're going to need to know some area formulas by heart. You're not going to be able to use a formula card again. So some area formulas. I would hope that you would know them, but this might be a good refresher. Area formulas. Start with a circle, since we did it last week. What is the area of a circle? Pi r squared. And what does r represent there? Radius. All right, so then a square or a rectangle. All right, it's going to be the same formula. Can anybody tell me what the area of a rectangle is? It's not. Those aren't necessarily the words.
Area of a rectangle?
It's length times width. So same as the area of a square, except for the square, all the sides are the same. So a lot of people like to say side squared, but I just say it's length times width. Okay. You'll need to know a triangle. Can you still see the yellow on the blue? Triangle. Okay. This is the one that most students get wrong because they just don't care to remember it. It's close to the one before. It is 1/2 the base times the height. I'll tell you why, actually. Okay, so here's a rectangle, correct? So a rectangle, technically, length and width are the same thing as base and height. We agree? Yes? A triangle, you've obviously, hopefully, split a sandwich diagonally like this. A triangle is half of that. So that's where the 1/2 base times height comes from, because it's literally a rectangle cut in half. That makes sense? What else we got? We need a trapezoid. Trapezoid. Area equals. So a trapezoid could look like this. Could look like this. Could look like this. So those are 3 types of trapezoids. I'm sorry they're not beautiful. You'll see them more when we get there. But it's also 1/2 B1 plus B2 times the height. So these are the only formulas for area that you'll need to know. You will need to know the volume formula when we get there. B1 and B2 stand for, B stands for base. But these are going to be the parallel sides, because there's obviously 4 sides in a trapezoid. They're going to be the parallel ones. So in this picture, I made these 2 parallel. You can't see that. I made these 2 parallel. I made these 2 parallel. These 2 parallel. So base doesn't necessarily mean they have to be on the bottom, but they're 2 parallel sides. Okay? Most of the time, they're the only ones that are given, but not always. All right, so these are all the area formulas. Again, no formula card. You'll just have to know them. Okay? So we're going to talk about volume. The volume of a solid is the number of cubic units contained in its interior. So it's literally asking how many little cubes, whether an inch cube or a centimeter cube, how many cubes can I fit inside? So there's this guy called Cavallari, and he noticed that if you cut them up, you remember when you did cross sections? Yes, no, maybe so.
Yeah.
Okay, you just did it last week. Cross sections, this would be a, looks like a rectangle. All right, so what happens is, if you find, listen, the area of the cross section, or the area of the top, you can multiply it times the height of the entire object, because what happens is, there are, like, I don't know, a ton of cross sections in an object. So here's what the formula is. Volume equals area of the base, you want to write this down, times the height of the entire object. I write it like that because I know the common mistakes that students make on this. So the area of the base times the height of the entire object. So this is the volume for a prism and a cylinder. Okay, a prism has how many bases?
1, 4, 6.
Nope.
1.
How many bases?
Oh, 2.
2 bases. And they will be identical in shape, in size, and they're parallel to each other. So base down here, base up here. Base down here, base up here. That won't always be the case, but we're going to talk about them. So this is a formula for the volume of a prism or a cylinder.
What's the second one? Height of what?
Height of the entire object. I should finish it. A lot of students don't understand what the height of an object is. The height is what pushes them, the 2 bases, apart from each other. So if this bottom piece is the height and this top piece is the height, what pushes them away from each other are these lines between them. Y'all see that? So height is not always going to be what you think it is. Okay? So we're going to talk about it. The prism is a solid geometric figure whose 2 end faces are similar, equal, and parallel. So 2 base figures. Not 3, not 4, no more than 2. Okay? And I actually gave you the common ones right here. What kind of prism would this be? Rectangular. We have a Kleenex box right here, so I don't even need that. So there are 2 bases, so 2 bases look like this. They're rectangles. And the height, even though it's sitting like this, the height is the distance between the 2 bases. So between my fingers, that's the height. Does that make sense? Height is not always going to be up and down. It's just the distance between the 2 bases. The next one, what kind of prism is this? Triangular. Again, a lot of people think it's rectangular, but there would be 3 rectangles. There's one here, there's one here, and then there's one on the bottom. So that's 1 too many. You can only have 2 bases. And it would be this triangle and this triangle on this end. Okay? I've never eaten Toblerone. Apparently it's like toffee. We talked about this, didn't we?
No, what is that?
I'm pretty sure it's chocolate and toffee.
What is toffee? It's taffy. Oh, taffy.
It's chocolate. I zoomed in and reading it. And toffee. I don't like it.
Where are you from?
There's a difference between taffy and toffee. She's
Very
from New York.
different. Taffy's like candy. Toffee's like toffee tastes like coffee to me.
Oh.
So there's see the word there.
I've never had it.
All right, and then what kind is this one? Triangular. It's like we don't need to discuss it. It's a triangular prism. Here's your triangle. Again, the height is going to be what separates the 2 triangles. The other triangle is on the bottom. All right, so we're going to begin finding the volume of a prism. So I wrote it in steps. We also will just do them. The first thing that I do to finding the volume of a prism is identify the face of the prism, meaning like the base's shape. So are we dealing with a rectangle, a square, a trapezoid, or a triangle? These are the only kind that you'll get. So identify it, because in order for you to be able to solve, you need to know what kind of shape you're dealing with. Make sure that there are only 2 of them, 2 bases. Write this down. That'd be helpful. Number 2, find the area of that base. So solely find the area of that rectangle or that square or that trapezoid or triangle. Because that area is going to get plugged in right there. Once you find the area of the base, you plug it in, then multiply it times the height, because that's the other part of the formula. And it's talking about the height of the entire prism. So, the reason I keep saying that, my last class could not comprehend this. So, when you have a triangle, okay, a triangle, right?
Right triangle.
This is a right triangle, yeah. So, there's a height and there's a base, correct? So, if you had a second triangle, don't hate on it. It's not working for me. hate on it, or like have an aerial view, whatever. The height is what pushes, like the height of the entire prism, is what pushes the two triangles away. The height of the triangle is a side of the triangle. This is like the most mind-blowing thing to students that they don't understand.
I didn't quite get that.
Height of the prism is what separates the two of them. Height of the triangle is literally a side of the triangle. We're going to do two examples of triangles.
So that's the height of the entire prism.
This is the height of the entire prism.
Okay.
This is the height of the triangle individually.
I got you.
You will literally see, I promise. Okay? The last step is to write your answer in cubic units. So reason being, area is in square units because that's two-dimensional. You're doing two-dimensional squares. Cubic units, volume, you're figuring out how many literal cubes you can fit inside of an object, and that's 3D. So that's where the cubed comes in. So you put a little 3, yeah. Not square, but a 3. If you have not written them down, I'm just going to talk through them on this problem right here. So I'll teach you how to draw it. Ready?
I think it's how to draw a prism.
I'm going to draw this
3D
one.
figure. That's wrong.
Okay. Draw a triangle.
Oh, I can't see.
My bad.
Just draw this triangle first.
What is this?
A prism has two bases. There are two triangles, so what kind of prism is this? Triangular. So you're going to draw an identical triangle on your paper, I don't know, maybe 2 lines below it, give or take. Identical to it in almost every way. Do your best. Just so you know, the bigger the object is, the better it looks. Oh, looks good. So you're going to draw a dotted line from the top of the first triangle to the top of the second. And then you will connect the other two sides. And you should have a wedge of cheese.
Should I draw something with cheese?
I mean, draw it on your own time. Alright, so after that, label 3 for 2 centimeters. So we've already all agreed that this is a triangular prism. So here's what you need to do first. Once you've identified the base, which is a triangle, that's step 1. Step 2 is to find the area of this base. The area of a triangle is 1/2 the base times the height. And it's talking about the base and the height of the triangle. So what I've highlighted in blue, those are the numbers we should be using. So 1/2.
Will one always be longer than the other? Will you be able to tell?
Not necessarily. What do you mean? Like the
The
height?
hypotenuse is always the biggest number.
Yeah. It doesn't matter here. This is multiplication. So you're going to take 3 and 4. It doesn't really matter which one you label the height or the base.
Oh, okay.
So because you're multiplying, these are the only 2 numbers you're given. One of them is a base, one of them is a height. But the formula has 2 numbers, and you're multiplying them. Doesn't matter what order you multiply in. No, it never does. So here's what you can do. You do not 1/2 both of them. Do you hear me? You only half one of them. Or, what's 3 times 4?
12.
What's 1/2 of 12? 6. So the area of the triangle is 6. So now you're going to go into the volume formula. Volume equals the area of the entire of the base. So what is the area of the base? 6. So the area of the base times the height of the entire object. So the height is what's pushing one triangle away from the other triangle down here. So what is pushing them away? 2. So the height of the entire shape is 2. So 6 times 2 is, and it is centimeters cubed. Do we have any questions on the first problem? Yes, sir.
Have you, I wasn't looking when you found out
Where do you get the 2 from?
Yeah.
This 2? The height of the entire object is what pushes the 2 bases away from each other. So I outlined the 2 triangles. The number that separates them, that's the height of them. So it's 2.
There's always going to be a 3. What that 3 for?
Cubed.
Oh, yeah.
Because you're finding out how many little cubes you can fit inside this object. Letter B. What is the face or the base of this object? There should only be 2 of them. That's trapezoid. We're talking about shape here. You're fine. Trapezoid. Everyone see the 2 trapezoids?
You're drawing in those lines perfect.
Well, thanks. If I can do one thing right today. So the formula of a trapezoid is 1/2 the base 1 plus base 2 times the height of the trapezoid. So we're only finding the height of what I've highlighted in blue, light blue. So area equals 1/2. The 2 bases are the parallel sides. We can automatically see one of them is 14. Where's the other one? 6. Here's why. These 2 bases are congruent in every way possible. So if it's a 6 down here, it's also a 6 up here. So plus 6 times the height of the trapezoid. So it has to be a part of the trapezoid. So can anybody take a guess what that number would be?
Wait, huh?
Oh, 3.
3. So there's a 3 here. You see that red line in a box? That shows height of something. When you go to the doctor's office, they make you stand up straight to take your height. Am I correct? So what it's showing you is that this red line and the 14, that line, they make a right angle together. That is called something in geometry. When 2 lines form a right angle, what is that called? Perpendicular. They're perpendicular to each other. So this is the absolute height of the object. Nobody measures height. Nobody measures height at an angle, right? That would not be the height of an object. Nobody's going to measure you if you're like, I don't know, leaning or something. They're going to measure the absolute height, which would be a straight line right here. So that's where that 3 comes in. So you're going to do 1/2. What is 14 plus 6? 20 times 3. You can do one of 2 things. You could do 1/2 of 20. What is 1/2 of 20? 10. Do I have to do 1/2 of 3 now? No. I've seen too many kids do that last hour. If you take 1/2 of one number, you don't have to do it again. What's 10 times 3? 30. So the area is 30. You could have also done what's 20 times 3? And what's 1/2 of 60? 30. So either way, you got the same answer. Once you find the area of the base, so area of the base, all right, which is, we said 30. We're going to multiply it times the height of the entire object. The height of the entire object is what pushes the 2 shapes away from each other. So what? It's 5. I'm going to tell you right now, the height of the trapezoid and the height of the entire object will most likely, I'm talking 90-95% of the time, will never be the same answer. There may be one case where they are the same number. There may be one case where they are the same number, but they're not going to be in the same location. Does that make sense? The height of the trapezoid was 3, and it's on the trapezoid. The height of the entire prism was 5, and it's what separated the 2 trapezoids from each other. 30 times 5 is? Then centimeters cubed. That is the volume of the entire object. Questions? Comments? Okay. I'm going to do one more with you. You what? I have no idea. He just said something and went, nope, I'm going to go back. Okay. There we go. All right, so I'll teach you how to draw this one as well. You're going to be drawing it very similar to the first one. It just won't look as pretty. Draw a triangle that looks like this. Devin, stop turning around and messing with them.
I was picked. Okay.
Yeah.
Whatever's happening.
What is it, TV?
Kind of like a tent, yeah. Well, teepees are, I think, more round than. Ooh, that looks ugly. But you know, the bottom is.
I can't.
The bottom is like round. That's
Yeah,
so I can sit down. Denver. You're going to draw a triangle exactly like it. You want to go to the right and then up a little bit. So, draw a line similar to this one. Similar to that one.
Oh.
So go to the right and then up just like a little bit. Maybe like a line or something. And draw a line that is parallel to this line or similar to that line. It's okay if it's not perfect. From the top of each triangle, you draw a straight line. The bottom of each triangle, draw a straight line. And then if it's inside the triangle, draw a dotted line. Doesn't have to be perfect. Just enough so that you can tell it is a triangular prism.
Oh, my junk kind of clean.
You're welcome. Okay, so what is the base, Denver? If I have to say your name one more time. Thank you. What is the base of this object?
6.
The base is going to be a shape, not
triangle.
triangle. A triangle. I'm asking the shape of the base. I'm not asking the number, the shape of the base. So we need to find the area of the triangle because volume equals the area of the base
Times the height of the object.
Yeah, times the height of the entire object. You get it. Object. Okay, so what is the area of a triangle?
times 1/2.
Okay, I already had some students get this one wrong, because you're about to do one. Get this one wrong because they refused to look at their notes. I don't know why.
What you mean?
1/2, like the next one's going to be a triangular prism like this.
Mm-hmm.
And they got the area of the triangle wrong because they didn't use the correct formula.
Gotcha.
Future notes. So A equals 1/2 base times the height. So this one, it's very easy to see the base and the height. It's labeled very simple. What would the base be in our triangle? 6, because here's your triangle. 6, and then your height is 4. So it doesn't matter what order you multiply in. What's 1/2 of 6? 3. So then you'd have 3 times 4, which is 12. You could also just done 6 times 4, which is 24. Half of 24 is still 12. Doesn't matter.
You can do it like that every time.
Every time. The only thing is you cannot take half of both of them. You see what I'm saying?
Yes,
We only took half of 6. Yeah. Volume equals the area of the base. What was our base? The area of the base was 12. All right, and then height of the entire object. The height is what pushes the two triangles away from each other. 9. 12 times 9 is 108 centimeters cubed. Wow, everything's in centimeters today. That's a teeny tiny tent. Okay, you're going to go to your classwork paper and you're going to do 2 problems. Here's what I want to tell you, and I will only say it once. So make sure you look at me. You do not have to draw the picture. If you fall behind and I'm moving on, you need to draw the picture. I will tell you a few minutes before that happens. So you do not need to draw the picture. I am going to help you a little bit on the first one. So you need to make sure you pay attention. Don't say, I don't get it. It's going to take your knowledge from chapter 9 for a second, dealing with triangles. Okay, so look at this. This is classwork. I'm only going to say this once. So what kind of prism is this? Triangular. There's a top and a bottom. The top and the bottom, they're going to be congruent in every single way. What kind of triangle is it? Right triangle. Opposite of the right triangle is 15. What other side were we given?
The base. Or not the base.
We were given 9, right? Because these two sides are congruent to each other. Here's what I want you to write down. What is 15? What kind of side is 15? The hypotenuse is never the base or the height. Never.
So 15 is distance.
So, when whenever you're finding the area of this triangle, will you use the number 15?
No.
You will not. You would use this missing side right here. How do you find the third side in a right triangle?
Standard form. Or not standard, the equation.
The Pythagorean theorem. That is my hint to you. Find this side so you can find the area of the triangle. Go. Hypotenuse is never the base or the height because it is a diagonal and not a completely horizontal or vertical line. So, we're going to do some problems like this. Okay, so letter A, if you don't know how to draw a cylinder, you're going to draw a pretty wide circle. Same exact formula. Second one just lean in. It's like the leaning tower of Pisa. Like if you were to find, I'll explain that one in a second. It wasn't a joke. It was like it was for real. The leaning tower of Pisa is like that. Have you ever seen it?
I'm so confused.
How are you confused? We haven't done anything.
Not this. Okay. Yeah.
All right. So you're going to take a couple lines and draw a circle identical to it. So they put dotted lines. Listen. They put dotted lines to show you that it's inside of the shape. I mean, do whatever you want. It's okay. And then you draw straight lines to connect the two circles. So circle, circle, straight line, straight line. Doesn't have to be perfect, doesn't have to be pretty whatsoever. None of you look at your notes anyway. Some of the girls do, I'll say that. So letter A. If you also don't know how to draw it, these are the examples that are in your textbook. So you could open up your textbook and draw them. So, letter A. The first thing that you need to do is find the volume of the circle. Or sorry, volume. Find the area of the circle. Area equals pi r squared. So what is the radius in this problem? 9. Alright, what is 9 squared? So the area is 81 pi. A lot of you struggle with understanding when to hit S to D. If you were to hit S to D right now, would you have to round? Yes, you would be rounding in the middle of the problem. When you're in the middle of the problem, leave it in terms of pi. So just leave pi there, okay? It makes your life easier later on. So, we're going to do, from here, the volume equals the area of the circle, which is what?
9 pi, or 81 pi.
81 pi, not or, but 81 pi, times the height. The height is what pushes the two circles away from each other. 6. This is the end of the problem, correct?
No.
Well, it's about to be.
Yeah.
We're about to be.
Yeah, about to be.
Whenever you answer a problem, you will not use pi. You will hit S to D, unless it says otherwise. So, type it in your calculator. You do not have to say it out loud. I want everyone to be able to have a chance to type it in their calculator. It will be a big number because 81 times pi is 81 times 3.14. And then times 6, so it's going to be a larger number. And that's okay. You should get 1,526.81, what are we in, feet? Cubed. At the end of the problem, you should hit S to D, yes. The next one. So listen, if you were to Google the height of the Leaning Tower of Pisa, a lot of students would think that it's like this line I just highlighted in green. But would you ever measure the height of something like that? No. So that's why if you look, there's like a right angle out here. That's because height is from the horizontal line to a vertical line. So from the ground is straight up. Okay, so we're going to do the same exact thing that we just did. We're going to find the area first. Area is pi r squared. What is the radius of the circle? It's 4. So this is where a lot of you go wrong. Is 4 times 2 the same thing as 4 squared?
No.
What's 4 squared?
16.
So you should have 16 pi. I cannot tell you how many times on a test I saw 8 pi. Struggle. Alright, so volume equals the area of the circle, which is 16 pi, times the height of the entire object.
7.
7. We're ending the problem, correct?
Yeah, so that means you gotta press S to D.
Yeah, now we're going to hit it. Go ahead, I'll give you a chance to type it in. Now I'll let you tell me.
351.8.
And it is centimeters cubed. Cubed, because it's 3D.
Wait, so we did put square on accident?
It's not going to mark off the whole problem, no.
Okay.
Questions, comments, concerns? I believe you're going to go to classwork now. Yep. Does it say the word classwork? Find the indicated measure. Find the height of a cylinder with a base radius of 8 inches and a volume of 2010 cubic inches. So the volume of a cylinder equals the area of the base, just writing out the formula, times the height of the entire object. Or in this object, it's a cylinder. So we're going to plug in everything we know. Do we know the volume? What is it?
2010.
Yep, 2010. Does it exactly tell us the area of the base right now?
No.
Can we find the area of the base?
Yeah.
Given what?
With the radius.
The radius of 8. So the base of a cylinder is always a circle. So the area of a circle is pi r squared. What is the radius?
16 or 80 or 64 pi.
The radius is 8.
Oh.
You're good. You're about to tell us the area.
I apologize.
8 squared is 64 pi. Is everyone okay with finding the area? What do you think we do with the area?
Plug it in.
Plug it in for what?
The base.
The area of the base. 64 pi. Do we know the height?
No.
That's what we're looking for. So you can write h. So what is happening to h?
It is being multiplied by 64 pi.
So what's the opposite of multiplying by 64 pi? So you type exactly that into your calculator. I am pretty sure you get a whole number. Pretty close to a whole number. I think it rounds up to a whole number. A whole number.
So 10.
Nope. Oh, shoot. I don't know where that went. You're supposed to get that. For false information. Oh, man. Technical difficulties. Yep. 2010 divided by 64 pi. You should get 10. 10, and it is inches. Is it cubed?
No.
No, it's not even squared. It's just inches. Your calculator, again, is not the same as ours, so I do not know what to tell you. How many times do I tell them this at least?
No, but like, it's
Okay. We still have 2 more screens. So, similar objects. We're going to be dealing with them in both this section and the next one. The similar solids, they're the same shape but different sizes. So one is smaller, one is larger. You're going to use one formula, and it is the same formula as the last section. So the volume of the first over the volume of the second. Yes, dear. Equals the side of the first over the side of the second squared. You're given the radius. Mrs. Marshall, could you move over a little bit? Yes, Candace, I would love to.
What you trying to leave?
Yeah. Is everyone okay with the formula?
Yes.
You're going to do this in this section and the next section. I'm not asking if you memorized it. I'm just asking if you're okay with me writing it down. So the volume of the first, what did they give me as a volume?
Oh.
Everyone see that? 45 pi. Is everyone okay with that's the volume?
Yes.
So if it doesn't say pi, you cannot just add pi. The next one is not going to say pi. So you don't put pi. What shape does pi only deal with?
Triangles.
Circles. Always circles. Do you know the volume of the second? That's what we're finding. So I'm going to write V. Equals, so they gave you the two radius. What's the radius of the first? What's the radius of the second?
6.
Do you guys want to know like a life hack here?
Sure.
What is 3 over 6 reduced to?
1/2. 1/2 squared root of 6.
No. Is everyone okay with that? You can reduce. I haven't told you that you can reduce because I've seen your reducing skills. They're terrible. So 45 pi over V. I haven't done anything with that. What's 1 squared?
1.
What's 2 squared? 4. So you square. Once you have one fraction set equal to another, what do we do from here?
Cross multiply.
Yeah, cross multiply V times 1 is V. So V will equal whatever 4 times 45 pi is. So they're answering in pi. They didn't write it. Sorry, my pi looks Chinese. Pi, the volume of the first. The volume of the first is written in pi, so you could technically write the volume of the second in pi. I'm telling you, for your quizzes and tests, we're not going to do that. So hit S to D. Oh, I thought you said 108. Sorry.
Oh.
Sorry. Hit S to D with 180 pi. 0.48. And centimeters cubed. Sorry if you can't see that. You do have one more classwork problem. Ready?
Yeah.
Once you have finished this, you may turn in your paper and go. If how'd you already know this was a problem? Oh, it was already on the board. Yeah. So if you're good, then you can hand it to me and go. Have you finished all of the classwork problems?
That first one, with that Pythagorean theorem.
Why did you find an extra sign?
I was going to talk about.
Doesn't matter which one you do. Okay, pause this.